Hello, Year 11. And for our final lesson of this week, we are continuing to look at functions. We are going to be continuing to look at composite functions, but today we are going to be looking at how we can express a composite function using algebra. So today we are expressing composite functions using algebra, and I'm just going to remind you that a composite function is a function of a function. So previously in the last lesson, we were substituting numbers from one function into another function. Today we are going to be substituting algebra. So I've said to express a composite function using algebra, we have to substitute one expression into another. And also on top of that, we may have to simplify the expression. So let's see this with an example. It says, given f of x is 2x take away 10, and g of x is x plus 3, calculate f g of x. And it says, write your answer in the form ax plus b. So our final answer is going to look like so many x's plus or subtract a number on the end. So how do we do this? Well, instead of substituting g of x into f of x as a number, we have to substitute the algebra. So we know that g of x is x plus 3. And this is what we would substitute into where x is in our expression for f of x. So what we need to do is 2 lots of g of x. So I'm going to write this using a bracket. G of x is x plus 3. So we're doing 2 lots of that, but then we've got to take away 10. Now obviously we can do a little bit of an expansion here, because 2 bracket x plus 3 is 2x plus 6. And then we've got this take away 10. So that will tidy up all together to be 2x take away 4, which is in the form ax plus b, where a is 2 and b is negative 4. It then says use your answer to evaluate f of g of 5. So all we can do now is we don't have to do this separately. We can substitute into this expression straight away. So fg of 5 is 2 times 5, take away 4, which is 10 take away 4, which is 6. Now we can actually double check that this is working by doing g of 5, taking that answer and putting it into f of x, just like we were doing last lesson. So let's just have a go at that. If our value was 5, if I put that into g of x, 5 plus 3 would be 8. I then take my value of 8 and substitute it into f of x. 2 times 8 is 16, take away 10, also gives us 6. In our second example, I'm going to try and bring back a little bit of previous maths that we've already done. It says, given f of x is 4x take away 10, and g of x is 5 bracket x plus 2, calculate f g to the minus 1 of x. So what that means is we are doing the composite function of f with the inverse function of g. So what I'm going to do is I'm going to work out what that inverse function of g looks like first. And because I prefer doing it this way, I am going to use flow diagrams. So what does g of x mean? It means that I'm adding 2 and then timesing by 5. So if I'm wanting to work that backwards using an inverse operation, I would need to divide by 5 and then subtract 2. So what does that look like using algebra? Well, that would be x over 5 take away 2. So that is my g to the minus 1 of x. Now the question's asking us to do f of that value. So I'm going to have to substitute my expression for g to the minus 1 of x for x here. So it ends up being 4 bracket x over 5 take away 2 minus 10. Now that's a little bit messy, but it does tidy up. If I have a fifth of x and I'm timesing it by 4, then I just have 4/5 of x, which I can write like that. 4 times negative 2 is negative 8, and then I've got this take away 10. So tidying up even more, 4x over 5 take away 18. Then says use your answer to solve f g of negative 1 of x equals 0. So that's just asking us to make an equation and solve it. Well, we've already got our expression. So it's saying when does 4x over 5 take away 18 equal 0? So I'm just going to solve this like any other equation using inverses. My first inverse is to add 18 to both sides. Adding 18 to both sides is 4x over 5 equals 18. Now I need to multiply by 5 because I don't like that divide by 5 on the bottom. So remember that just moves the divide by 5. So we end up with 4x equals 90. And then to finish off, I am going to be dividing by 4. And obviously a nice mental way of dividing by 4 is to halve and halve again. So I think the answer to that one is 22 and a half. Thought for the last example, I would actually find an AQA exam question, just to see the sort of standard that you might have. This was one of the more difficult questions that I found on this topic of functions. So first of all, we've got for all values of x, f of x is x squared plus 1, and g of x is x take away 5. So there are two functions defined. And the first part of the question says, show that f of g of x is x squared, take 10x plus 26. Well, you know I like questions like this. Whenever it's a show, you've already got the answer, so you know what you're aiming for. So this is f of g of x. So I'm going to be taking my expression for g of x and substituting it into f of x. So f g of x is going to be x take away 5 is what I'm substituting in, but then I need to square the whole thing and then add 1. So I can expand this using FOIL. And remember, I've got a plus 1 on the end. Looks a little bit like the difference of two squares now. But anyway, expanding, we've got minus 5x plus 25. So that's just using FOIL. And now collecting terms, we do in fact see it is x squared minus 10x plus 26. It then had, I think that question was worth 2 marks, and then this final question is worth 4 marks. It then says, solve f of g of x equals g of f of x. So it's asking us to set up an equation and solve it. We already have the first part of the equation. What we don't have is what g of f of x is. So I'm just going to work that out. This expression is slightly easier because we are substituting this into here. So the x is going to become x squared plus 1. And we've just got take away 5. So this is x squared take away 4. So what we need to do now is we need to equate these two things, and you'll find that in the extension questions that I've set you, I've set a very similar question to this. So we need to say, when does this equal this? So when does x squared take 10x plus 26 equal x squared take away 4? Well, the first thing that you might immediately notice is I've got an x squared on both sides, so those cancel. But what I'm left with is negative 10x plus 26 equals negative 4. And I hope you would recall, we don't really like negatives on our x's, so I would add 10x to both sides first. Once you've added 10x to both sides, we have 26 equals 10x take away 4. And from there, it's relatively straightforward to solve. We're going to add 4 to both sides. 30 is 10x. We would divide by 10, and the answer is 3. So for today's questions, I'd like you to try some questions from the textbook. I've put a link in the instructions to my PowerPoint. So the PowerPoint will have all the questions that are there. There are 3 normal questions, and should you like a little bit more challenge, I've put a couple of extension questions down, one being very, very similar to that final GCSE style question. Okay, there are answers to all of these questions in detail on my PowerPoint, so feel free to, at the end of the lesson or 5 minutes before the end, check your answers carefully and make any corrections. So I doubt you'll need to contact me this lesson, but if you do need to, you can do so in the Ask the Teacher channel.